Hello students, welcome back again. In this part we will discuss about superposition of two SHM when they are in same phase or out of phase, or they are in same dimension or maybe perpendicular to each other. So let's begin the topic. Let's begin with the topic superposition of two SHM. When we have two independent simple harmonic equations in two dimension or maybe in one dimension, either they may have same frequency or may not be. Now there are few terms we need to understand about these, like we can say that resultant oscillation at orbits. So when superposition of two simple harmonic vibrations in one dimension means like one equation y equal to y1 equal to a1 sine omega 1 into t, another equation y2 is equal to a2 sine omega 2 into t. When they are in one dimension but they have different frequencies, so the resultant frequency can be calculated omega 1 plus omega 2. Before going to the result, I would like to tell you, if one equation y1 is equal to a1 sine of omega 1 into t, another equation y2 is equal to a2 of sine omega 2 into t. We are talking about the resultant, that y is equal to y1 plus y2, and we can say that a1 into sine of omega 1 into t plus a2 into sine of omega 2 into t. If a1 is equal to a2, so we are getting a sine of omega 1 into t plus sine of omega 2 into t. Carrying this mathematical relation, we are getting twice of a sine of omega 1 plus omega 2 by 2 into t into cos of omega 1 minus omega 2 by 2. So we are getting the frequency, we call it as average frequency, average angular frequency, and resultant amplitude is 2a, and that can be defined by the cos function, cos of omega 1 minus omega 2. So we are getting resultant oscillation at the average frequency omega 1 plus omega 2 by 2. So when we have two SHM in one dimension may have same amplitude but different frequency, they would have average frequency as omega 1 plus omega 2 by 2. Now the case of amplitude. Amplitude varies from 0 to 2a. 2a is the maximum, 0 is the minimum. It is decided by the cos function, cos of omega 1 minus omega 2, we can say. Now amplitude, as it is given in the third part, amplitude varies between 2a and 0 under the influence of cosine term as a much lower frequency omega 1 minus omega 2 by 2. Acoustically, this growth and decay of amplitude is resisted as beat of a strong reinforcement when two sounds of almost equal frequencies are heard. So beat is actually the difference of frequencies heard by ear or any observation phenomena, like air, like drum, or like any audio from the mic that is heard by the observer, and difference of frequency is just as beat. So this function is just called as beat. Now second part, how we can deal its mathematical part, like superposition of two perpendicular simple harmonic motion having equal frequency. When they have equal frequency, we will proceed x is equal to a1 sine omega t plus phi1, another as y equal to a2 sine omega t plus phi2. Eliminating t and getting general equation of the ellipse. So x square upon a1 square plus y square upon a2 square minus 2xy upon a1 into cos of omega 1 minus omega 2 is equal to sine square omega 2 minus phi2 minus phi1. Actually we know that the equation of ellipse is x square upon a square plus y square upon a2 square, a1 a2, that is equal to 1. But here we are getting this is not equal to 1. That's why it's a case of Lissajous figure in a particular rectangle of different amplitudes along x-axis and along y-axis. Because we have two variable displacement, that is along x-axis and along y-axis. That's why we are getting x square upon a square plus y square upon a2 square. And it is just Lissajous figure that can be seen in the next slide. Now second part, superposition of two perpendicular simple harmonic vibrations having different frequencies. When the two SHMs are perpendicular to each other and having different frequencies. So when the frequencies of the two perpendicular simple harmonic vibrations are not equal, the resulting motion becomes more complicated. Of course, the pattern which are tracked are called as Lissajous figure. In those Lissajous figure, amplitude along x-axis and y-axis varies or may same. That could be discussed in the next slide. If the amplitude of the vibrations are A and B respectively, the Lissajous figure will always be contained within the rectangle of side 2A and 2B. The axial frequency bear the same ratio, can be seen like that. In the first part, we can say omega is x is the angular frequency along x-axis, omega y is the angular frequency along y-axis, that can be decided with their amplitudes. And having ratio omega x upon omega y is equal to 2 when they have phase difference 0. Second part, when the phase difference between these two waves are 90 degree, then the ratio of their angular frequency would be 3. Omega x upon omega y, that is equal to 3. In the third part, we can see if we want to know the ratio of angular frequency along y-axis to x-axis, it is equal to 2. But the variation is of amplitude. Means displacement of the SHM along x-axis is equal to 2a and displacement of SHM along y-axis is equal to 2b. That can be seen over here, and the ratio is equal to 2. Now in the next part, we would like to find the ratio of angular frequency along y-axis to x-axis, that is equal to 3. So of course we can say 3 turn along x-axis or along the amplitude 2a and 1 turn along y direction and having ratio 3. So in this part we discuss superposition of two waves. Either they are in same dimension or perpendicular to each other. We find that they actually shows Lissajous situations, and we find out the ratio of their angular frequencies, that is just a constant. Now we'll proceed to the question. In this question, a 0.5 kilogram cart connected to a light spring for which the force constant is 20 Newton per meter oscillates on a horizontal frictionless track. So first of all, we will note down the given data. In the given data, we are given mass is equal to 0.5 kilogram. Now with a force constant, so K is equal to 20 Newton per meter, oscillates on a horizontal frictionless track. In the first part, calculate the total energy of the system and the maximum speed of the cart if the. So first of all, we know that total energy is always a constant function, that is equal to 1 by 2 m into omega square into a square, or we can say 1 by 2 k into x square. If the amplitude of the motion is 3, so x is just the maximum displacement, that is equal to a, so we can say that is equal to 1 by 2 ka square. So we can say 1 by 2, the value of k is already 20 Newton, a is 3 by 100 whole square. Solving this mathematical part, we will get the answer of a part of the first part. Now the maximum speed, so we know that maximum speed is always v equal to a into omega. So a is actually the maximum displacement called as amplitude, that is given as 3 cm. Omega is just the angular frequency that can be calculated from the ratio omega is equal to under root of k by m. K is given, mass, so that can be 20 upon 0.5 and it is equal to under root of 200 upon 5, that is equal to 40 under root. So from this value we will get the value of omega, and substituting over here, that is equal to 3 by 100 multiplied by under root of 40. The answer we will get, it is just a part of first one. Now part B, what is the velocity of cart when the position is 2 cm? So we know that velocity as a function of displacement at any time, that is equal to omega a square minus x square. Omega already we calculated, a is given as 3 cm, x is given as 2 cm. So that is equal to under root of 40 under root of a is given as 3 square minus 2 square divided by 100 square. So in this way we will get answer. Now part C, compute the kinetic and potential energy of the system when the position is 2 cm. So kinetic energy is equal to 1 by 2 m into v square, or we can say 1 by 2 m into omega square a square minus x square. Already omega we calculated, a is given 3 cm and x is given as 2 cm. So on substituting these data in the equation we will get answer. And similarly about potential energy, so potential energy is actually equal to 1 by 2 k into x square. So k is given, that is equal to 20 Newton per, and x is given as 2 centimeter. So in this question, we are about to ask the kinetic energy, potential energy, maximum velocity, or the total energy, in which we use the formula for total energy is 1 by 2 Ka square. A is the amplitude called maximum displacement from the mean position. Kinetic energy is 1 by 2 mv square, where v is equal to omega under root of a square minus x square, and in case of potential energy, that is equal to 1 by 2 kx square. So we put these corresponding mathematical equation for the according to the desired value we want to know. So we got the answer of these three questions. In this part, we discussed about superposition of two simple harmonic vibrations when they are in same phase or out of phase, may have same frequencies or different frequencies when they are in one dimension or perpendicular to each other. I hope you are enjoying the lectures. Now, in the next part, we will discuss IIT-JEE questions asked in the examinations. So stay tuned with us.